Okay, good. Be alive. And I'm just eating a cookie, so, so it's a bit early. We're going to make a start in a few minutes. And Natasha, yes, Cleo is really happy to have her slave around all the time. Um, so, yeah, I think she's just left here. She just went downstairs to fetch the coffee and in the hope of some food, but anyway, she might be coming back in a minute. Okay, we are making a start in about 5 minutes or so. Can you hear me okay? Somebody just say yes or no. If I don't get an answer, then we've got a problem here. Let's have a look. That seems to be okay. Okay, good. Okay, so I should stop crunching my cookies here. Um, Thanks for that. Thanks. I'm not sure how much delay is on the system here, so it might go up and down a bit. So if you send me a reply, I might see it a lot later if there's a problem. So please bear with me with that. Okay, so today we're going to do pumps and shafts. I can see the talk in real time now. I've got different software, so it doesn't cover the second screen, cover the talk. So again, just bear in mind there's a delay, so I may not respond straight away. I may respond like few seconds, then 20 seconds later or something. Okay, I'm gonna wait a little bit more. Okay, so 10:30, just a few more minutes. Anyway, thank you very much, to come online and to, work with me on this. It's a very strange time we are in at the moment. This early in the morning, I went out shopping, and I've never seen it. You would think the end of the world is happening tomorrow, but then again, you wouldn't have to buy all this stuff to survive. But it's just really, really crazy. I've never seen anything like it at this time in the morning. I don't know what it's like where you are, whether the whole world is going slightly off the rails. Hey George, good to see you on. Daisy, it's unit 310. 310. Rana, good morning to you as well. I'm just looking at the chat who is on here. Okay, I don't. Cameroon, good morning. I think I missed out on you there. Good to see you on. And yeah, hope I haven't forgotten anybody. But anyway, thank you very much for taking the time to come online here and to take this through. We've got a few lectures to go, and then we are done with this unit. I'm not sure. We've still got next week to go. The instruction I've got from Gary is to start on 315. So a lot of stuff we've done in 315, we've already covered in 308, but maybe it doesn't do any harm to go through it again. Yeah, Harrison Joe, good morning as well. I just see you coming on there. I'll wait a couple of more minutes. I think there might be a few missing, and then we make a start. And obviously, you can see the video later on as well. I will make all the PowerPoints available, so you can. You don't have to take notes. That's basically what I'm saying. So I make all the PowerPoints available, so you can peruse them or go through them at your own time and take your own notes, or just upload the PowerPoints to one file as proof that you have covered it. Okay, a few more minutes. The cat's in the window. So just checking out, making sure nobody encroaching on her territory. So I'm not getting pestered by her, which is good. Right, a couple of minutes and then we make a start. I'm not sure what's happening. I can see on the viewers here that the numbers go up and down. I'm not sure whether the connection is okay, or any feedback would be really helpful to me as well, to see whether this works. I used a different system before, and I had a lot of problems with it, and I'm hoping that YouTube, or using YouTube as a platform, is a lot better. Okay, I'll let you know. I'll send an email out. I'll upload them somewhere on a web space, and then I'll send you an email, and you can download them from there. So and Natasha, spot on. The YouTube channel as well. So they're not the PowerPoint. So they're the talks. They'll be there. The lectures will be there. The lectures we are doing now, they'll all be saved on the YouTube channel. So when you go to the link and you click on the channel, you see all the lectures, and you see the same lectures I've done in the past as well. Maybe they were better than now. I don't know. I'll let you know. I'll send you an email. I sent an email around, and I still haven't got a place. I don't think the college has anything provided. I think there's maybe a facility on the VLE, but I'm not sure whether I can access it from outside the college to upload stuff. I've got some web space available, stuff I do for other people, and I can use that. Right, let me just turn the speaker off here. Just my mother is just sending me some stuff through. You've just seen it there. Anyway. So that should be stopped now. Okay, let's make a start. Okay, thank you, George. Thank you for the report. Okay, today we're going to talk about pumps and shafts. The criteria, it's Unit 310. The criteria are 4.1, 4.2, 4.3, and 4.5. There's another lecture which we going to do this afternoon, and this lecture is going to be on just pumping gases, which is a little bit different to pumping liquids. For heat exchange, we may be looking at gases or looking at liquids to pump them around. Okay. This is what we'll be looking at today. So we've got describe the application of different types of pumps. Describe the application of shaft seals. Shaft seals, again, very, very important, and we're going to look at them later on, and it also comes up in the exam, but when we do the focus session, we're going to look at all the importance of shaft seals and the questions that or the knowledge you need to have for the exam. Explain the need for lubrication in systems transporting fluids, and describe the equipment used for lubrication of seals and bearings. So this is what we're going to cover in this lecture. Okay, move on. Transport of coolant and heating, and that's obviously is very important. So you've got a heat exchanger, and that's what we looked at a few sessions ago. And you get 2 bits of liquids going in and coming out, and obviously you could possibly get away with just hot water or hot liquids rising up and cold ones going down, and you get a little bit of movement in the fluid, but it's normally not enough for heat exchange. So we need to have pumps to deal with this, and to move water through the heat exchanger at force, and to make sure that everything is going through okay. So next question: what is it called when we move a liquid or a gas for the purpose of either cooling or heating it? What term would we use to do this? Farshid's thermodynamics, that's right. I don't know how much delay is on the line, so the answer might come quite late. Okay, what is it called? So we're moving a liquid And we are moving, for the purpose of a heat exchange, a hot liquid through a medium. And again, we've got the three areas. We've got radiation, conduction, convection. Which one is it? Convection, spot on. And what type of convection? Do you remember what it's called? Somebody? It's a problem with the delay. I know, I can see on the screen here that it goes out quite a bit later. It has to encode everything and then it goes out. It's convection, spot on. But what type of convection? We've got two types of convection. Can you remember the term for that? Or somebody, please. Forced convection, spot on. Thanks, Josh. Thanks for that. Okay, we're looking at forced convection here, and that's really what we need a pump for and what we use pumps for with the heat exchange. Yeah, great. Thanks. All typing at the same time and coming through. Forced convection, spot on. Okay, so we're looking at two types of pumps. We're looking at displacement pumps and centrifugal pumps. First question is, what is a centrifugal pump? And that's the wrong key. And we've got an explanation here. So a centrifuge is something which pushes something around and rotates it, and we get centrifugal forces. And with that, we try to move a liquid or a gas into a system. We've got an explanation here. A machine with a rapidly rotating container that applies centrifugal force to its contents, typically to separate fluids of different densities, for example, cream from milk or liquids from solids. A centrifugal pump is a machine that uses rotation to impart velocity to a liquid and then converts that velocity into flow. Okay, velocity, again, just another term for speed. So it rotates really, really fast. We get a lot of speed injected into the substance, whether it be a liquid or a gas. And that in turn is then turned into a flow, and that's a centrifugal pump. Right, let's move on. We've got another slide here. Centrifugal pump is a machine. Every centrifugal pump includes an assembly of mechanical components to make operation of the pump possible. Okay, and we have got a pump that is mounted on bearings. So again, there's a maintenance aspect. So if you've got these pumps, the bearings eventually will wear down, so they require greasing as well to some extent. There's a sealing mechanism that keeps the pump from leaking excessively. So again, you've got a bearing, you've got a shaft, and this talk is about pumps and shafts, and at that point you've got potentially a problem that whatever you're trying to pump through, whether it's a liquid or a gas, that there's a leakage within the pump, and that's pretty much a problem with every pump you're likely to come across. Structural components designed to handle the stresses and loads imposed on the pump during operation, so that's part of it as well, and wear surfaces that allow the pump to be repaired and returned to its original specifications. Yeah. So these are all parts of a centrifugal pump. I've got tons of pictures here in a moment, so you can see them all. Yeah, so we've got one example here. You've got an impeller. You get the liquid in. It's sucked in from where it says suction, and then it's pushed out through the discharge. Yeah, so it's good for either a liquid or a gas with low viscosity, or liquid with low viscosity. Actually, it's high viscosity. It needs to be very not as opposite to solid. Yeah, it needs to be very liquidous. I'm not sure what the term is, but if it's some liquids they've got a higher viscosity, a lower viscosity. That's a lower viscosity. I hope I'm getting it right. So with a lower viscosity, they're more like a solid, and it gets harder for a centrifugal pump to push them through. So normally we use displacement pumps for those type of liquids. Okay, we've got another picture here as well. So we've got the impeller. You can see the inflow from the side view. Let me just use the mouse. So this is the side view. You've got the inflow here, so that would go straight into there, and then you've got the discharge as well. Okay. Right, just another one, just a little casing. You've got the impeller here, you've got the shaft turns it all around. You've got the impeller here, and you can see as well, you've got these seals here as well. So, quite important. We're going to look at those seals in a minute. They've got a big job, so it's not just making sure that no liquid is coming out, but it's also trying to get rid of excess heat. Yeah. So we've got these seals here, just another picture of the pump, and we've got another one. This is what they look like for real. Thanks, George. Thinner. Yeah, viscosity, another term, thinner. Good point there. I'm just looking at the chart here. Okay, big question. Do you have these type of pumps? Do you recognize this pump from what you have at work? They're normally really good for water stuff. Yeah, stuff which doesn't require a lot of pressure, so you don't need a massive pressure buildup. If you have to build up pressure of some form or another, normally displacement pumps are better, and they are the preferred option. Okay. I'm going to stop for a moment just to see whether there's a response. Question: do you recognize these pumps from what you're doing at work? You have, okay. Jimmy, what do you use them for? For pumping liquids, I assume. Getting stuff into bottles, or. Okay, thanks, Natasha. Okay, any more responses? Or it's a bit of a problem with the delay. I'm about half a minute ahead of you. So okay, I'm gonna move on. My assistant has just come. Okay, it's just another displacement pump. Just a couple of pictures, just to let you see what they look like. Again, just follow the cursor. You've got the shaft at the back, so you would have a motor, possibly a 3-phase motor, attached to that, and then you would have the pump body. Okay, production lines. Pumping product to the production lines. Okay, thanks for that, Jimmy. Thanks. I'm just watching the chart. Again, sorry for all the delays and stuff. Would be interesting as well if you can let me know what the delay really is, whether it's about half a minute or a minute or something, so it gives me an idea on how to work with this. Okay, Ryan, I'm just reading this. Yes, different to that, though, was replaced with displacement pump because of high viscosity. Okay, yeah. That makes sense. Okay. Right, and so anyway, that's what it is. Straight away you can see as well, possibly when you look at this diagram, that you've got issues here with the shafts and the seals as well. So you would have, when you look at the mouse here, you would have a seal down here to make sure that the liquid stays where the liquid should stay and doesn't come out. You would have some bearings on the backside as well, and possibly more seals as well. Okay. Right, just one more example. So you can see the motor right at the back here. So this might be a typical 3-phase motor. Okay, thanks, Jimmy, for that. Thank you. 45 seconds today. Okay, thank you. Helps me a little bit on how to work this and not to rush too fast if I ask you a question. Okay, you can see the motor at the back here. And you can see in this diagram where the actual pump is, the centrifugal pump. And again, you can see the seals as well. So that's really what we are sort of concerned about at the moment, the seals as well as the pump and then the different types of pumps which we have. Okay, the next one is displacement pumps. We've got positive displacement pumps which make fluid moves by trapping a fixed amount of and forcing or displacing the trap volume into the discharge pipe. And the beauty with displacement pumps is you can increase the pressure a lot higher. So if you've got like a lot of pressure to deal with a centrifugal pump, it just doesn't cope with it. It's good at speed and and sort of high-speed displacement, but not very good at dealing with pressure, on opposing pressure to deal with. Some positive displacement pumps use an expanding cavity on the suction side and a decreasing cavity on the discharge side. Yeah. We're going to look at, I'm not sure whether it's a fluid or it's in this unit. In one of the units, we'll be looking at all the different pumps, and we look at vane-type pumps, piston pumps, and how they work and what you can do with it. And right. So that's what we are going to be doing. I don't know whether you can hear this. My cat has been eating some grass outside and is just sick on next to me. I don't know whether you could hear this, but anyway, she's okay now, so we can carry on. Right, these are the different types. You can see them here. We've got the right, okay, good. I think she's okay now. We've got the different types of pumps here. We've got an external gear pump, an internal gear pump, and we're going to think it's maybe in fluid mechanics. We're going to look at these pumps in a bit more detail. We've got a lobe pump and a vane pump, and you can see how they work. Let me just go through all of these pumps. So the external gear pump, you've got some gears, they move into one another, and they force the liquid into a certain direction. Then with the internal gear pump, you can see that there's a cavity created where the liquid goes in, and then it is forced out on the output on this side. And it's similar with the lobe pump as well, where you get an opening and it then shuts down and it closes it as these things turn round, and the liquid is forced out. So anyway, that's what's happening here. And then we've got the vane pump. In the vane pump, you've got like little springs in these veins, yeah, and they sort of push against the edge, and sort of the liquid comes in one side and is then sort of pushed out the other side through these veins, and those veins, they sort of go in and out. You can also straight away see the problems as far as wear and tear is concerned with all these pumps. So for the external gear and the internal gear pump, you've got wear and tear on the gearing itself. Similar to the lobe pump as well. There's hardly any gap in between them, so they almost touch, or de facto touch, to press the fluid out. And so they wear down over time. And with the vane pump, you've got even more stuff to deal with. You've got little springs which are in these veins, and again, they wear down after time. The beauty about the veins is the veins themselves wear down. There's a little bit of play in them with the springs, and they will adjust themselves, and some possibly they last a bit longer than the other ones, as they are sort of self-maintaining to some extent. It would be interesting to know whether I think the normal is similar to motors as well. If a pump goes down, you just change the pump, and you don't worry too much about everything else. You don't really change the gears, I would think. I mean, I don't know what your experience is at work. If a pump goes down or starts being not quite as efficient, what do? Do you just change it, or how do you go along? Okay, I'm going to wait for about a minute now for some responses. Any responses to that? Quickly to repeat the question. Do you do any pump maintenance? Have you done any so far? Okay, thanks George, thanks Sarah. It's probably the same as three-phase motors. They go down, you just change them and you send them away, or okay, I'm gonna move on. Riley, service the pump, change the vane seal bearings. Okay, thanks for that. External contractors, yeah. Yeah. I think that's probably pretty much what most people do today. Have the pumps refurbished. Okay. Yeah. Okay. So your job basically is to just change them over, I would imagine. Okay. George, how hard is it to change the vanes in a pump? Is it an easy job or is it quite finicky? Okay. All done externally, Fash. Okay. Again, I'm just sort of thinking as well, for the benefit of those who watch the video later, which I think is one or two people who are not here. Probably have to. I've noticed that the live chat doesn't come up on the video, which is a good thing in a way. So, but probably have to just quickly repeat of what you're saying in the chat here, and then yeah, we can go on. Okay, right. Let's move on. So we've got a piston pump here, and so this is one type, yeah, for positive displacement pumps, and then we have the piston pump as well. So we've got liquid suction going in, we've got a bunch of valves, you can see them here. You've got a suction valve and you've got a discharge valve. And so the stuff is sucked in and then is pushed out. Yeah. So I mean that's sort of fairly straightforward, fairly easy. And it's pretty much like a car engine as well. Right, okay, move on. Just a couple of pictures of various pumps. I'm just trying to figure out which one this is. Not sure. Okay, we've got the membrane. We've got a diaphragm pump as well. You can see them in the PMC when you go downstairs. And it's the machine which is near the window downstairs towards the back of the wall. There are quite a few diaphragm pumps in there, yeah. And one of the things which tend to get changed is the diaphragm. That's one of the things which goes and need changing. Again, there's a plunger. The plunger causes the plunging action, yeah. And so it causes the suction and the discharge. And again, you can see this as well. You've got the suction here. So as the plunger goes back, the liquid or the air gets sucked in. And then the plunger goes forward, and then that ball seals the suction point, and it can be discharged. Yeah, it can be discharged out. So that valve opens, and the liquid or the gas or whatever it is going to be discharged. Yeah. So that's how it works. That's a diaphragm pump. Quick question: how many diaphragm pumps have you got at where you work? I mean, can you identify them? Have you seen them? Okay, George, just reading what he said. Very easy. It takes about 10 minutes or so if the others have not snapped it in the inside and they're stuck. Okay. Okay, that's, thanks for that. Thanks for the update. Diaphragm pumps, anybody? Are you using them? Can you recognize them from the image here? Let me see if I got another image of... no. No. Loads, okay. Yeah. What is the biggest maintenance issue? Is it the diaphragm? That's what I always thought with them. That based on your experience, is that the thing which you have to change most often? Okay, I'm just waiting for it. It's the 45 seconds which I need. Okay, thanks for that, Ryan. Josh. Okay. I would imagine maybe possibly places like Coca-Cola or Prince's will have more diaphragm pumps because of the amount of liquid you have to move with. And possibly less so at Hovis, I'm not sure, because the liquids you're dealing with are probably bigger. Okay, thanks Natasha for that. Okay, so right, let's move on. We've got about half an hour to go. Okay, so again, just to sort of remind you, so far we've been looking at two different types of pumps. We've been looking at centrifugal pumps, and then we've been looking at displacement pumps. And within displacement pumps, we've been looking at sort of 5 different types. Yeah, so just go back. So those pumps, and then we've got the diaphragm pump as well. Got a pump and a motor configuration. You can see as well the motor is, let's see, a box standard 3-phase motor. And then the pump is just this tiny weeny bit at the front of the motor. Yeah. So that's what does the pump action. Just a picture, that's all. Okay, we've got a diagram, which again is important, and for the exam you will have to write about this a little bit. So the big question is centrifugal pump versus positive displacement pumps. Selecting the proper pump is important. So you look at flow rate, suction lift, the total amount of pressure you can generate, fluid characteristics. Let's go through this sheet here. So we've got couple of areas here. We've got mechanics, performance, viscosity, efficiency, and inlet conditions. So it imparts centrifugal pumps imparts velocity to the liquid, resulting in a pressure at the outlet. Pressure is created and flow results. So centrifugal pumps normally, if you need to generate a lot of speed with your liquid, they're good. They're really, really good and very, very fast. They do create some pressure, but if you need to create a high pressure, high level of pressure, they're probably not as good. Positive displacement, it captures confined amounts of liquid and transfers it from the suction to the discharge port. Flow is created and pressure results. Okay, performance, flow varies with changing pressure. That's a problem. And for positive displacement, flow is constant with changing pressure. Yeah, so you can generate a constant flow, and regardless of pressure, because providing the pump can stand up to the pressure, on the other side of the pump, it's not a problem. It'll squeeze the liquid through and make it work. Viscosity. Efficiency decreases with increasing viscosity due to frictional losses. So increasing viscosity means it's thicker. Low viscosity means it's thinner. I'm getting it right now, aren't I? I hope so. Anyway. So let's rephrase this. Efficiency decreases with thicker liquids due to the frictional losses inside the pump, typically not used on viscosities above. We've got a figure here, E850 CST. I'm not sure what that means. Efficiency increases with increasing viscosity. So I would think, for example, when you look at hoses, and I'm not sure, please correct me, that if you've got a displacement pump and you have to pump dough, into a vessel, that you would have a positive displacement pump to do this job, to get this dough moved across the system. I'm not sure whether you would do this or whether you would just pump the ingredients and then mix up the dough, but somehow you have to move the dough into the forms to bake the bread. I haven't been to a hose plant, so I'm not sure how you do this, but I would think that positive displacement pumps are probably more suitable to the stuff which is done at hoses. Please correct me if I'm wrong. Efficiency peaks at best efficiency point. The higher or lower the pressure, efficiency decreases. Efficiency increases with increasing pressure. Okay. And then the inlet conditions. Liquid must be in the pump to create a pressure differential. A dry pump will not prime on its own. Okay, it's very, very important. So if you've got a centrifugal pump, you have to have a liquid inside the centrifuge for it to work, to create negative pressure, to create the suction for the stuff to come in. Negative pressure is created at the inlet port. A dry pump will prime on its own. So that means providing it's airtight, the displacement pump, it'll start pumping the gas, create suction until the liquid arrives, and then pump the liquid through. So yeah, that's how they work. So positive displacement pumps better if you need to create suction and you don't have liquid present at the inlet when you want to use. Okay, makes sense, makes perfect sense. So you would use a positive displacement pump. Saying that a diaphragm pump is supposed to be a positive displacement pump, but probably doesn't work. You're right, doesn't work with thicker liquids. Okay, Ryan says you use pumps for crossing paste, and then because of the high viscosity. Yeah, so yeah, that makes sense. Makes perfect sense. Okay, right. Let's move on. We've got a couple of questions here. What type of pump is better for liquids with very high viscosities? What pump can be started in dry conditions? What type of pump is ideal to produce pressure at the outlet? Right. Need to wait for about 45 seconds. Gonna have a look at my clock and have a sip of my coffee and give it a go. Give us some answers here in the chat room. Any answers? Okay, Ronna, yeah, that makes sense. Just to go back on the diaphragm pumps. Yeah, it makes sense to use it for cleaning chemicals. They've got a weird sound, that's what I noticed, the diaphragm pump. Okay, number one, what pump is better for liquids with high viscosities? Okay, yeah, okay. Yeah, Josh, spot on. Yeah, so centrifugal pumps are ideal for pressure at the outlet. Yeah, spot on. What pumps can be started in dry conditions? What type of pumps? Yeah, for one, pressure displacement pumps, spot on, Harrison. Thank you. Okay. Thanks, Vash. Yeah, I go along with that. Basically, anything with a high viscosity wouldn't work with centrifugal at all. Yeah, so you would have big problems there. It just wouldn't work. Okay. Number two, pumps can be started in dry conditions. Yeah. Okay, I'm sort of waiting a few seconds more. I'm sorry for the delay. It must be quite horrendous because whilst I'm waiting, I'm not saying anything, and then it's all delayed. External gear pump can be started in dry condition. Yeah, okay, that's fine. Thank you, Josh. Thanks for that. Okay, I'm moving on. We've got about how many minutes left? We've got about 20 minutes left, so let's move on. Shaft seals. What are the issues with shaft seals? Yeah. So again, you can see a pump here. And we've got a diffuser, an impeller, and then we've got a shaft seal here. And obviously one problem is that they wear down after some time, and once they wear, they start leaking. And we've got all sorts of issues. We've got abrasive or aggressive chemicals or liquids we're dealing with. We've got problems with heat when the thing turns around, when the shaft turns around. We've got problems of trying to keep everything sealed up. And so they are sort of the main issues we are dealing with when we're looking at shaft seals. And we've got a list here. I've got a list here. So the shaft is constantly rotating. And because it's constantly rotating, it makes sense as well. There's a massive potential for wear and tear. Yeah? So just imagine you've got a pump, and the pump is running for a year in a row. And you've just got this little flexible seal, and it's just rubbed against all the time. Yeah? And it's a problem. The shaft rotates against a stationary casing. Again, always have to bear this in mind. So if you didn't have the seal, you would have a shaft. The shaft would go against the casing, and it would just wear it down. So we need to have something which can be easily replaced, which is very sturdy, it's very flexible, and at the same time it's got sealing properties. So it's quite a job these shaft seals have got to do. The pump produces a pressure which will try to force liquid out of the shaft. Yeah? Again, that's another point as well. So you're not just dealing with the rotation, the casing, bad chemicals or bad liquids, which can be quite aggressive to whatever substance you're using for the seal, but you're dealing with pressure as well. Yeah, so there's pressure against it, and the liquid, like I mentioned before, the liquids pumped may affect seals, and so it's a major maintenance issue. So when you look at pumps, probably the biggest issue you are likely to come across are those little seals which have been used for the shaft itself. And again, it's not like a normal seal. If you've got like a washing machine and you put a little seal in and you plumb in your washing machine, that thing never moves for the life of the washing machine. And with lime scale and stuff like that, if there's a tiny weeny weeping going on, it tends to seal itself. Now with a rotating pump, it's not the case. Yeah, so from day one, it's like a battle, for survival for the seal. Sounds terrible, doesn't it? Like little furry animals being used for this purpose for pumps. But anyway, just to move on. So when you look on here, you can see you've got a pump which has been in this type of diagram, and you can see where those seals are. So you've got like seals all over the place, and to try and keep the liquid inside the pump. So you can see this on this diagram. Again, 11, you can see the seal there, so one of the main seals. Okay, let's move on. This is just a list of, or an image of different seals you're likely to have inside pumps and how they work. You can see some have got like a spring attached to them to try and press them onto something, so keep some pressure going. Obviously, lots of them, there are different types of rubber, and it's quite a job to try and make these things work. Obviously, a lot of science, a lot of work has gone into them. Little anecdote, I remember when I was working on the sewage plant, there was a company, and they were looking at rubbers, types of rubbers which may be used for seals, and they were actually taking these rubbers and putting them in one of the sewage pools, the pool where they've got all the oxygenation going on. And the problem is you've got oxygen, you've got aggressive chemicals, you've got aggressive bacteria which are in there, and pretty much everything is against those seals. And every couple of weeks they would come and they would take the rubbers out and look at them and see how fast they have weathered or withered or whatever you want to call it. And it was quite interesting to see, what was happening to them over time. And they were just doing research in trying to create really strong, resilient types of rubber, which could be used for seals and things like that, withstanding all sorts of chemicals. And they reckoned that sewage was one of the most aggressive substances they could come across, especially in an oxygenated pool. Right, we've got just a couple of pictures about shaft seals, so you can see there's a shaft and seal there as well. Sort of try and put this in. Okay, again, just pictures, so I'm not going to spend too much time on these seals. Yeah, and there's an interesting one as well. This is a marine seal. Let's have a look. I've got this. It's they use. Try to remember what they use. It's a textile. I can't think of the name of the textile. It's It's a textile which is woven together, and the whole idea is, and obviously you've got a boat, you've got a shaft. The shaft has got a propeller. The propeller drives the boat, and inevitably the shaft goes into the water, and you don't want any water to come into the boat. Yeah, makes sense. And so they have this type of seal, which apparently is really long-lasting, and you've got the problem with salt water as well, potentially, when you go out to sea. And as water sort of penetrates this textile, it actually expands and seals the water, or stops the water from coming up the shaft. It's quite interesting. It's just I thought of this and I thought I stick it in. It's probably not as relevant for you, but it's sort of an interesting concept of what they're using for boats. Right, just a couple of pictures. You can see as well, you can see where the seals are running here. We've got the shaft here, and you can see those shiny surfaces where the seals have been running along the shaft. And you can see this here as well with the shaft. And again, one of the problems with seals is if you seal it too heavy, it generates friction. Friction generates heat. You need to get rid of the heat. If the grip of the seal is too tight, it will the wear and tear will be much more. Yeah, so you have to replace them a lot more often, and so you've got all these issues to deal with when you're looking at pumps and seals. Okay, just a couple of more pictures of different types of seals, commercial seals, and we're going to talk about lubrication now. Very important. Lubrication of shaft seals. First question is, why is it necessary to have some type of lubrication for shaft seals? And the answer should be obvious. I'm going to wait for a couple of seconds. Just give me some ideas. Why do we need to lubricate shaft seals? What happens if we don't lubricate them? Okay, just waiting for a couple of answers. Yeah, wear out. What happens as well? What is, if you don't lubricate them, what would happen to this whole arrangement of shaft and seal and both rubbing on top of one another? And okay, so I'm just going to read out what you've written. Because of friction generated, accelerated wear will occur. That's by Ryan. Spot on. Jimmy, reduce friction, wear and tear. That's obviously for lubrication. You put lubrication in, so you reduce friction. Riley, shaft can struggle to rotate. Yeah, spot on. Sarah Shan, to slow down the process of wear and tear. Rana said to minimize friction. Spot on. Okay. Yeah, so the shaft could seize. Yeah, that's sometimes what's happening with machines when lubrication is no longer there. They just seize, and the reason why they seize, Harrison, spot on. They get hot. Yeah, they get really, really hot, and then you could just have a catastrophic breakdown. Efficiency, spot on, Rana. It's a big point. The efficiency goes down, and it's a big problem. Thank you for that. Okay. Right. Reduce wear and tear of the seals as they might run on dry surfaces. There's more friction, and provide additional sealing capability. That as well. Okay. I'm going to move on. It is necessary for a radial shaft to seal efficiently over a long period of time. The sealing lip must be lubricated. This reduces friction wear and tear of the sealing lip and to the shaft. The lubricant is used to dissipate heat generated by the seal. So we have to have some dissipation of heat. So dissipation means getting rid of heat, which is generated by the seal. And obviously it would just break down over time. This is what it looks like. So you've got like a seal, and then you've how are they lubricated, Ryan? Okay, spot on. This is the picture. So you've got a little oil container or a lubricant container, little pipe. The pipe goes onto the seal, and then over time a little bit of like a drop of lubricant is delivered to the seal on a constant basis. Again, I wish we were PMC. I could take you. Thanks, Sarah. Loop point on machines. Okay. Thank you, Sarah, for your contribution. If we could go to the PMC, you can actually see this on, again, the one machine which is right at the towards the wall on the left-hand side as you walk in near the window downstairs. That one has got one of those loop points on. Okay, move on. We've got water lubricated systems, so we've got for cooling and lip sealing and reduce friction along the lip is just, again, done. And then we've got the good old grease gun as well. I used to, not necessarily for pumps, but when I was working in steelworks, I had to do this on a Monday morning or Friday afternoon, depending, whether I did it on a Friday afternoon or not. I had to do it on a Monday morning. I forgot about it, but one of my jobs was, before I started using the machines, I had to go around with the grease gun and grease shafts all the way through. There weren't pumps as such; they were used for just rotating machines, like oversized washing machines for bolts and deburring actions. And that was one of the jobs what you had to do. And partly I thought it was just, at the time I thought it was just like surplus to requirements, because you squeezed the grease in, and you were just pushing the old grease out, and you were just wiping it off, and then. But I mean, you did this on a regular basis, and doing that, you could guarantee that there was always fresh grease on the shafts of those motors. And that was one of the routines, one of the maintenance stuff I had to do on a regular basis. If I didn't do it, I was in trouble. Okay, right. How many slides have we? I think we are coming closely to the ends. Can use runner. Can't you get a seal for life bearings? Yes, you can. But it depends on the. I think in automotive it's done a lot, where you've got your shaft for the camshaft, which is it the camshaft? There's a shaft which goes out and it drives the water pump and things like that. And there used to be a seal in there, and it normally lasted about the lifespan of the car. So providing you didn't have too high a pressure inside your engine, the oil would stay in there, wouldn't be forced out. So yes, you can. But it just depends on the expected lifespan of whatever the machine is. Okay, we've got a car water pump. You can see what they look like. And again, the greasing for these pumps, like Rana, you said, they've got like a seal inside. And that seal pretty much lasts the lifespan of the car. Every now and then they do go down. In my time, I had to change a few of them. One question is, what type are they? What type of pumps are they? Are they displacement types or centrifugal types? Can you tell by just looking at them? Somebody. Ryan, centrifugal. Yeah, spot on. Thank you. Okay, I'm going to move on. List 5 issues you may have with shaft seals. Amongst yourselves, can you just go for it? 5 issues you may have with shaft seals. Bit like what we talked about before. Okay, I'm just waiting for some answers. If you just write them down. Again, this is an exam question, so damage worn out seals. Okay, thanks, Vash. Okay, a few more. So we've got 2. Wear and tear, pressure. Okay. Let's have another 2 and then we move on. Heat, chemical attack. Yeah, spot on. Okay. Pressure buildup, serviceability, shaft wear, replacing seals, wear and tear. It's a maintenance item. Okay. And we are at the end, so it's just about right within an hour. There are 2 types of pumps. Name them. So we've got... okay, thank you. Thanks, Jimmy. And Josh. Yeah. Actually, that's a good one as well, Josh. When if they're not aligned 100% or they're not running around the shaft, it's a big problem. Pumps sort of go down pretty fast and seals go as well. Okay, just a summary. That's the end of it. There are 2 types of pumps. Name them. Which are they? PD and centrifugal. Natasha, thank you. Yes, Riley, it is. It is. One advantage for each type of pump. Advantage for centrifugal, and 1 advantage for PD. Thanks, Sarah. Yeah. Okay, I'm just going to go ahead a little bit. What is the purpose of the shaft seal? Obviously, one of them is to seal, but what is the second purpose as well? Especially with a lubricant. What is it trying to do? Get rid of what? And that's pretty much the answer for the last question as well. Okay, PD can draw in liquids with high viscosity. That's good. Thank you, Ryan. PD good for high viscosity, yeah. Dry start for PD. Centrifugal works well with less viscous fluids. Yeah, spot on. Thanks, Josh. Centrifugal can run at high speeds. Yeah, thank you. That's right. Get rid of heat. Okay, that's for the following question. Thanks, Jimmy. Josh, disperse heat from the friction. Excellent. Great. Yeah. Okay, thanks, Sarah, for that, in friction. Okay, I think that's it, yeah. Summary we looked at, that's what we've done. And we are done with this, just 1 hour, just about in time. Quick question, what is the best time for you? Is it 2:30, 2 o'clock for this afternoon? Just one more lecture on gas pumps. What is the best time for you guys? Yeah, thanks. You're welcome. Just a quickie. I know there's a massive delay, so missing either. Okay, let's see. 2, please. 14:30. Thanks. 2 would be best. Just trying to look for a consensus. 2:15. Good idea. 2 o'clock because we leave work at 3:15. Harrison. Okay, that's a good point. Okay, let's say we'll have the next session at 2 o'clock. 2 sounds good. Okay, 2 o'clock. Okay, so I'll send you another email with the link, and then we'll be back on at 2 o'clock. I'll try to save this presentation, and you can go through it at a later stage if you wish to do so. Okay, guys. Anyway, have a good lunch break, and I'll see you back at 2 o'clock. Okay. Okay. Bye bye. Okay, City. City later. See you at 2. Okay, 2 o'clock.